Hey guys, welcome back. I love how David Schmidt talks in that last video about the case studies and really all of the work that has gone into just understanding more about what Lauren Picard originally discovered with the copper peptides, right? So now you understand a little bit more about copper peptide and the relationship to stem cell technology. You know, when you start talking about regeneration and resetting genes, it's nice to know that it's backed by science. And so in this next short video here, he's going to go into a little bit more about stem cell science and how it started, some of the pitfalls and the costs and the different things like that, and then just give you a little bit more information about how LifeWave fills this gap to be able to get towards regenerative medicine and how it can be done efficiently and affordable for everyone. So guys, listen in and we'll see you soon.
Let's restate this problem. The problem is that as we age, the stem cells are aging with us. This, of course, has to do with the Hayflick limit. There's a limited number of times that cells can divide, and the stem cells are subject to the Hayflick limit along with the rest of the cells. So quite simply, when we get to around age 70, age 75, our cells stop dividing. And this is really bad news. Anybody that has gotten over the age of 60 or 70 knows that their ability and their capacity to heal and recover from an injury has slowed down dramatically. This is a result of a degradation in the quality of the stem cells, their ability to proliferate, their ability to release growth factors, and eventually, of course, we don't have any more stem cells. So most of the solutions that companies are looking at is let's take young, healthy stem cells and inject them into the body. And there is not a major success of this that's available today. Most governments have not approved stem cell therapy. There's only very limited approvals. Most of this has to do with bone marrow transplants. And that's because there are significant risks that are associated with injecting stem cells. If they don't divide the way that they're intended to be used, they could divide into cells that are not supposed to be in the tissue where they are injected. So for example, in Japan, there has been ongoing research into Parkinson's disease. And there's a human study going on right now where a needle is inserted into the brain and stem cells are injected directly into the brain. Well, when this research first started, stem cells divided into muscle tissue, liver tissue, hair, and the animals ended up dying because the stem cells divided from a pluripotent state down into a multipotent state that was not desirable. The division was uncontrolled. So these are some of the risks associated with stem cell science as it is today. But of course, that's going to change in the future. So what we want to do is make stem cell science affordable, safe, effective, and available to everybody. So how are we going to do that? Well, as Robin was saying, I have over 100 patents now. I reached that milestone this year. Those are 100 issued global patents with many more that are pending. And over 70 of those are just in the field of stem cells and regenerative medicine. And we've spent over $4 million over the last 12 years in developing X39. And research, of course, is ongoing as we find new ways to utilize our technology with respect to stem cells. Some of the early research we did was with the National University of Ireland in Galway at their Regenerative Medicine Institute. This research was actually funded by Scientific Foundation Ireland. And Remedy, by the way, and NUIG, is in the top 2% of universities globally in the field of stem cell research.